Introducing Zaxby's new chicken finger tacos. One with pico and creamy chipotle ranch, and the other with bacon and avocado ranch. Chicken expert since 1990. Taco expert since now. Woo, saucy! Zaxby's.
We're excited to announce that our very own podcasting platform, Zencastr, has become a new sponsor to the show. Check out the podcast discount link in our show notes and stay tuned for why we love using Zen for the podcast.
You're listening to the Archaeology Podcast Network.
Hi there, welcome to the Archaeotech Podcast, episode 149. This is your host this episode, Paul Zimmerman, and today we have a special guest co-host, Eric Olson. Chris Webster, who's normally the host of the show, is busy right now, so the two of us are taking the reins, and we're going to drive this right off the tracks, I'm sure. But today's conversation, if you're a regular listener, this is episode 149. The previous episode, 148, Eric was our guest. And we had some great conversations. Eric's been on twice now on this podcast, and we've had some very interesting conversations with him, both on air and off air, how he likes to approach teaching archaeology, how he likes to approach teaching tech. And one of the things that came up in the last episode, which we figured would make a good run for this episode, would be how do you deal with actually starting on tech? Because so many of the different tech kind of projects that you see, what you see is something that somebody has gotten to a certain point at that they're very adept at. And so that barrier to entry, you look at it and you think, oh, I could never do that. And it's daunting. But you and I, Eric, and I'm sure most of our listeners have all had projects that we've done that we were absolute rank newbies at the start. And we got over that fear. We got over that phobia and we jumped in. I mean, for me personally, I'm cocky. I think that I can do anything until I'm proved otherwise, which I get proved otherwise. But I always come at it like, oh yeah, I can learn that. But I know that not everybody's like that. And I do know that kind of trepidation when you're dealing with something that's entirely new, especially some new tech program, whatever it is, programming language, whatever you might be faced with, either because you've heard about it or because it's been presented to you in a work or school setting you have to deal with. And so, Eric, because you have a lot of experience actually working with students, it makes a lot of sense to bring you in on this discussion so that our listeners can kind of get a sense of some of the things that you and I have dealt with and some of the ways that we've gotten over the initial fears or how we've actually found resources that we found useful for us. So anyhow, that's our intro for today's episode. But I totally got this backwards because I'm new at the hosting thing. How are you doing, Eric?
I'm doing good. Hi. Yeah, I'm just thinking about technology and how we can get people to be less scared of it and more willing to learn how cool and efficient it can make your workflow and make research better. So I just wanted to add, you said sometimes things get intimidating and you start talking about coding. I also think something that intimidates people is math, but we can get into that potentially. Yeah, I know mathematics, but I have a fun way of teaching that. Whether or not we get into it, we'll see.
Well, that fun way of teaching that is actually what I took away from our first interview with you last year when you were on the show. You had a really full-throated endorsement of community colleges, and you were singing the praises of the students that you have. You said that they're coming at community colleges from all sorts of different backgrounds, disadvantaged in various ways, non-traditional in various ways, and that they tend to come to your class with a real hunger to learn. And that to me was really a great thing to hear. I mean, I've got my own fancy PhD from a Ivy League institution. And I don't think that, the top level, pardon me for using that terminology, but the high price tag, elitist and elite institutions have a monopoly, have a lock on, either good students or good teachers. And so having a teacher like yourself come on and say how great these students are, and then also having your Tri-C, Cuyahoga Community College, and they have given you a long enough leash that you can experiment and you can do field work with your students and you can teach them and work with them on these various projects is also really cool. So, it's kind of a triangulation of interest between the school, the teacher, and the students. And that fills me with joy to hear.
Yeah. And I also want to commend you for saying it correctly. I believe Chris struggled with Cuyahoga Community College. It's really a tongue twister, which is why we usually just shorten it to Tri-C, just to save ourselves some time there. But yeah, the students at Tri-C are really willing to learn. Not to say all of them are, but certainly more than I think many people give a community college credit for. And I think a lot of students, and my Tri-C students included, get intimidated when I suggest learning things like R or Python or GIS or photogrammetry, or learning how to use relational databases. See how I segued there?
Nice.
But yeah, I think what we need to talk about is not just for students, but really people who aren't in school anymore, who think like, man, I really want to continue my education, whether that's at a community college where you have the opportunity to take some of these courses that I really think could benefit you. So the community college definitely fits that role of continuing education, lots of certificate programs, but also the fear of, well, R sounds intimidating. Coding sounds intimidating. So there are a few things that I thought we could talk about today that I think would really help dispel some of the fear and, as you said, kicking the tech phobias. And one of the first things I would suggest are some introductory readings, not to sound like a professor or someone who's planning a lesson plan around this, but I kind of did in preparation for today's episode.
Awesome.
Actually, I'm pulling a physical book off my shelf, and I do this on my other podcast from the archives, and this is always usually a fun sound. The sound of pages flipping. But this is Using Computers in Archaeology, a Practical Guide by Shannon McPherson and Harold Dibble. It's an old school book. It's I think 2002, but I read through it and I honestly considered using it as sort of a supplemental reading in an upper division anthro class or archaeology class, because it covers so much good content, like how to use a total station, how does GPS work, how does a relational database work. It even gives you there's a whole table on one of these pages for some people call it ASCII, some people call it ASCII, the character set for ASCII. So it goes through all sorts of stuff. It even explains a little bit of how binary works. It doesn't get too into the weeds, but it gives, I think, a lot of good overview on how computing works in general in a very readable and understandable way. And that's one of the two books I have. The other one I would recommend, and it's free. So the other one is free. This first one I mentioned is not, unfortunately, is the odate.github digital archaeology textbook. And we'll put a link in the show notes for this. But essentially, it's a online hosted and edited by multiple different professors and academics and researchers way of doing digital archaeology. So talking about sort of the same things as the other book I was talking about by McPherson and Dibble, like how does a database work and how should I organize my data in general, and how do relational databases work and all that kind of fun stuff. But I'll let you get a word in.
No, it's awesome. Yeah, that's a great resource. I just think it's interesting that you picked these two, one book that's almost 20 years old and the other one that is absolutely current. The older one, McPherson and Dibble, as far as I can find, there is no ebook or even PDF that you can get of it. So it's just paperback or hardcover, probably used at this point. And the other one, the ODate, is so new that it's constantly under revision. Right? That's the idea of it, to not be a static snapshot in time of a book, but to be something that educators, archaeologists can use, can update, can adapt.
You can even leave your own comments.
Yes, absolutely. So it's a living document. It's a different kind of book. It's re-envisioning of a book. Cool project on its own, but I'm glad that you came prepared with the reading list for today.
There will be a quiz on next week's episode.
Nice. Should we tell Chris?
Yeah. He'll be quizzed on it. So make sure he paid attention. But yeah, okay. I just thought I'd plug those two as like introductory readings. They're not going to be like your end all be all, but I thought they were good suggestions. And then there's obviously any plethora of things we could recommend for, say, R or Python or GIS or photogrammetry. But I think we should really start to unpack them as concepts first before we start doing like a recommendations and review podcast episode. Because I don't think that's what our intention necessarily was. But I certainly made a list of, things to look into and talk about in regards to all of these different technology topics or programming languages. And I think the first one to kind of get out of the way is talking about R, because I talked a lot about that on the last episode. And I ended up doing some deeper digging on Reddit forums And I don't mean to plug Reddit as well, but if you're not already using Reddit, I think it's got a lot of different, forums for discussion, like people who are working in the field posting questions, people who are in school posting questions. So there's activity there with what people are doing. So go ahead and check out the r/r programming subreddit or the r/GIS subreddit. People are asking questions all the time, and they may have questions that are identical to your own, and people will be more than happy to answer.
Is there a Stack Overflow R dedicated that you know
Probably.
Of?
I mean,
I would expect.
If you can think it, there's probably, they have such obscure subreddits on there. Like there's one called Where'd the Soda Go? And it's just GIFs of like infomercials, like that terrible infomercial stuff where they're trying, like they drop all their stuff.
Yeah.
So there's got to be a subreddit for that, but I don't know off the top of my head. But I would say for R, what I saw in these subreddits, at least in r/GIS, and I could post the specific threads that I'm referring to that I saw literally like last night before we started recording this, is people talking about how R was useful, but it's not something that they necessarily had to do to succeed in their job. And I found it interesting. I was talking up Python and R, but people who are GIS technicians and GIS analysts weren't really using R and Python a whole lot for their day-to-day activities. So like basic map making and analysis, they didn't really need these things, but for other tasks like labeling variables that don't exist within their data set, or running some interesting code. Essentially, I found it interesting that their perspective of it from GIS was very much it can really enhance your GIS game, but it's not necessarily something that like you are completely useless without knowing these things. So, and I think that's really the moral of these things is R can really, really help, but it's not something that you need to view as like, if I don't learn it, I'm going to be behind the curve. You might be in some respects, especially with statistics. A lot of hardcore statistics are done through R, such as principal components analysis, differential functions analysis, general precocities analysis, and MCA, which stands for multiple correspondence analysis.
Shocker.
Yeah, I know, right? But honestly, I would say learning how these statistical tests work is the more difficult part. Like, honestly, when it comes down to it, the stats can be more difficult than learning the programming language. Like R, I feel like is more straightforward in terms, because it's essentially like learning a written language. So if you can handle learning a little bit of a written language, and you don't have to learn the entirety of it, like you can learn enough Spanish to get by when you're in Mexico, right? You don't need to learn how to read Don Quixote in Spanish in order to get by, right? And the same is true of all of these programming languages, is you can learn enough to be familiar with it, have a competent conversation with someone who does use it, and really make your project management go better. Like you might not be the GIS analyst at your job or in, whatever capacity you work in archaeology, but knowing a little bit about Python and R and GIS might make it easier when you're talking to that person who has to do all of the work. And you're like, oh, this is going to be a slog for them if I just ask them, hey, can you figure this thing out? Like when you know what to do, you're like, oh, I'm really asking a lot of them. Maybe I should reframe my question.
Well, I like that comparison you make to learning a language. I mean, for years when I was active in the field, I would speak what we kind of jokingly called dig Arabic. I could talk about soils and about walls and about tools, and I could order food and ask directions and exchange some pleasantries, but that was about it. But I couldn't have a real good conversation with people, but it didn't matter for the most part. I mean, it was unfortunate that I couldn't. I really wish I spoke it better, but I could do my work. And so having that kind of an understanding too about any of the things we're going to discuss today is, I think, worthwhile. You don't have to be an expert to be able to use it just good enough to understand what it can and can't do, what you can and can't do, what you might be able to do if you put a little extra effort into it. So for our listeners who weren't listening to the last episode, R is a programming language, basically, but it's especially written for doing statistics, right? And so people who love R because it's the tool for the job, right? So it's really tightly bound to doing certain kinds of work, mostly around math and stats, and it's excellent at that. As I was saying last week, I've never really bonded with R. I've used it a couple of times. I've tried to use it for some projects, but the syntax is weird to me, which brings up another thing, is that just because one person is good at something or one person finds it easy doesn't mean that you necessarily will.
Right. And just to full disclosure, you're talking about like being an expert and whatnot. I am not an expert in R. I am not an expert in Python. I am one of those people that knows enough to be familiar with it. But if you were to ask me like to code something in Python or R, I still would need to like pull out my reference material and make sure I'm doing it right. I'm not going to do it very quickly, but I know enough about it that I can appreciate when someone is working in those things. So I just wanted to make sure that was abundantly clear. I'm not coming from a place of like, oh, I can get the source code and crack the case with Python or R. R is weird. And what's more confusing is I was reviewing the manual, which is free if you just look up R-CRAN, R-CRAN, or R language. And it's actually the S language. And it was developed, I learned this over the weekend. It was developed by AT&T for apparently some other internal communication within AT&T. So you get into the weeds when you start talking semantics of like, well, R is technically run through the programming language S, but whatever. It's a confusing syntax nonetheless for some people. But I think once you're familiar with the programming syntax, you can at least pick it up. Like you can at least be like sort of like someone who learns French. They can at least look at Italian or Portuguese or Romanian or why am I blanking on the other Romance languages?
Spanish.
Yeah, Spanish. There we go. But you can look at the other Romance languages and say, oh, I know some of these words, or hey, that looks familiar. Like it's a little bit different in spelling, but I get it.
So 2 takeaways from this. One is tool for the job. Definitely makes it make more sense sometimes. And also to not get discouraged if you try and just can't get your brain around something. I've always used my metric for whether or not I like a program is if it works like my brain works, right? There's sometimes I have to retool my brain, but if the basic metaphors that it uses, if the basic workflow, the syntax in a programming language basically fits the way I think already, that's a much lower barrier. So, if you're beating your head against R, well, maybe that's not the worst thing that you at least tried and then gave up because, don't let that discourage you because there are other tools that might fit your own thought processes better. But again, for when it comes to stats, it's right now the hot thing. And a lot of anthropologists and archaeologists and various other kinds of social scientists have been getting quite adept at it and singing its praises, rightfully so. Why don't we take a little break right now and come back and we'll continue this discussion. We'll go from something that's a little more specialized like R, and I'm going to kick it off with something that's more generalized, but kind of fits the same space. We'll talk a little bit about Python.
Chris Webster here for the Archaeology Podcast Network. We strive for high quality interviews and content so you can find information on any topic in archaeology from around the world. One way we do that is by recording interviews with our hosts and guests located in many parts of the world all at once. We do that through the use of Zencastr. That's Zencastr. Zencastr allows us to record high-quality audio with no stress on the guest. Just send them a link to click on, and that's it. Zencastr does the rest. They even do automatic transcriptions. Check out the link in the show notes for 30% off your first 3 months, or go to zencastr.com and use the code Archaeotech. That's ARCHAEOTECH.
The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets, always on trend, always on sale. Plan your trip at Tanger.com.
Hi, welcome back to the Architect Podcast, episode 149. Today I'm talking with Eric Olson on how to kick your tech phobias. We finished up the last segment talking about R, and I teased that we'd be talking about Python. Now, Python and R get compared constantly nowadays. They get used in conjunction with each other. A lot of people kind of put one against the other, battle of the programming languages, because Python is increasingly being used in data science, which is typically for the last 5 or 10 years been R's domain. But I don't think that they're really in opposition. The way I want to talk about them actually isn't necessarily using Python for data science, though it's good at that too, but Python just in general. Now, Python is for me, the programming language that I most quickly gelled with. And some people find it very weird. It doesn't have a lot of the syntax cues that you have in other languages. It doesn't have semicolons at the end of the statements. It doesn't have curly braces to mark off chunks of code. A lot of it is actually indented to show you what the chunks of code are, which might have been a pain if you had an older text editor and you couldn't like fold your code up. But now that basically any text editor can do that, it'll collapse, with just a little click of your mouse off in the gutter, it'll collapse whatever block of code down to one line so that you don't have to, like search forever to find it. Anyhow, Python is a great first language to learn if it's going to be good for you at all, because it's so clear, it's so expressive in its syntax, but it's also gets rid of a lot of the stuff that I personally fidgeted with, which was all this silly formatting stuff. Oh, should I break a line here? Should I break a line there? Do I put the curly brace on this line or on the next line? It doesn't let you do that. It will not run if you don't format it properly. And if you're wondering what the formatting is, well, there's documentation saying this is how it's supposed to be. If it's not this way, it won't work. They have a whole ethic about how to program in Python with rules that make a lot of sense, like explicit is better than implicit.
Right.
Which if you've been programming for a while, once you see that, you're like, oh yeah, of course. I should just, be a little more verbose with my variable names. I should explain a little better. I should comment a little clearer. And oh, by the way, here's how I'm supposed to do an inline comment. Here's how I'm supposed to do a block comment. It just gets rid of some of that friction that I found. So for me, Python, even though I'm not a good Python programmer, I program it every damn day, and I liked it. I do know that at the school that I worked, that some of the comp sci teachers, for a long time, even though they were teaching Java, they would use pseudo Python. Not worrying about the exact function names, for example, but they would use pseudo-Python to teach the concepts because they found that the syntax was so clear then that the kids could get an idea of what the flow of the program was, and therefore they could translate that idea, that conceptual idea, to whichever programming language they were using for the lesson itself, usually Java because of the requirements of comp sci if somebody's going from high school to college. You've used it some though too, right, Eric?
Yeah, I think you bring up a lot of good points about Python. And I guess whenever I think of Python versus some of these other coding languages, I'm pretty sure when I actually took a data science class over a year ago, and we talked about the history of Python and how it was like developed sort of with the mindset of a pseudo coding language, because I guess you could get into the weeds of like it's technically not an actual like coding language, it's a pseudo language because it tells the computer what to do and all that kind of stuff. But it sort of takes away a lot of that fluff of brackets, as you were saying, but it still has a lot of that like that syntax information. It's just not cluttered up with symbology. And I like to think of Python as sort of like being less concerned with the equivalent of when you're working on an annotated bibliography or you're doing your references cited and people want like SAA style versus, AAA style or some other citation style. And I tell this with my students too, like, I don't really, care the difference between when you put a period in versus a comma. Now, obviously in a coding language, you get an error statement if that's the case, but you understand the grammar and the syntax of what's supposed to go where, even if you don't have the symbols that, like, even if I don't know that like Java, I think uses colons instead of semicolons. The function is basically the same. It's just a difference of what's being done in the sentence or in the line of code, I should say, that you're doing. And for me, Python is super easy. It's relatable. And there's certainly a lot of, self-help you could get on YouTube, but there's also a lot of like, what's the name of those kinds of classes that are like massive online open enrollment, like they're called MMO. They're not
right,
MMORPGs.
I can't recall the acronym for it, but there are a lot of them now.
Like, what is it? Yale has them, and I think Harvard and MIT is the other one I'm thinking of, have these online courses that you can take in coding, and a lot of them deal with Python because it's such a universal, useful language. I think of Python as something that I use for GIS if I want to use it for GIS. I personally have not used a whole lot of Python outside of GIS. I mean, most of it has been in coding, but I think knowing it can help you understand other coding languages. Like it's a primer on how coding languages should be formatted and structured so that you can then springboard to more complicated and harder to, I guess you could say, read coding. Like it's readable. I guess that's what I'm saying is you can look at Python and it just makes a whole lot more sense because it's more based on English than it is on, say, how a computer needs to read things. Like we don't think of things in Boolean phrases, right? Am I saying that right? Is it Boolean?
Boolean.
Oh, Boolean, my bad. See, they don't, when you're taking an online class in coding, they don't always tell you the way to pronounce things. You just read it and have to interpret. So Boolean, you don't think in Boolean phrases, but you certainly have to in computing languages. So, or coding languages, I say. So I guess that's my kind of plus to Python is that it's a great starter pack if you want to go on to other coding languages. Some people, Python is all they need, and then they don't need to learn these other coding languages, which is great. Going back to the GIS conversation, I mean, even people who are GIS professionals don't have to use Python a whole lot, and I think you'll do just fine without necessarily having these coding languages under your belt. But I really do think there is something to be said about knowing Python. It makes you more versatile in the workspace. It makes you work better with your peers because you have an appreciation for what they do. And I think there's a lot to be said of that. Just like we as archaeologists, when we deal with city planners or, bigwig administrators who have no understanding of how archaeology works. Like if you're someone who works in a city government and you have familiarity with archaeology, then you're usually the person who has to talk with the archaeologist, right? Because you understand a little bit of what's going on. Even if you don't do archaeology, you can translate for other people. And the same is true of, I think, Python.
No, I think so. I think that's a good point about it. I think this is a totally aside, but Boolean, I had a long time ago as an undergrad when I was an engineering major before I switched to anthro. The teacher who was teaching us Fortran always said, instead of apostrophe, he always said apostrophe. So I can't see that word now without hearing the mispronounced word.
Was he a native English speaker?
No, he wasn't.
Oh,
so
okay.
I won't pick on it. It's funny that that's just stuck in my head, 30 years later.
English is a weird language.
Yes, it is. Python also is a very versatile language. Like I said, it's been used heavily now, increasingly heavily in data science. And it's also a worthwhile language to learn if you are getting into a tech or tech adjacent job, because it's one of the top one or two most popular languages as of early 2021, and it's been increasing in usage quite a bit across all sorts of different domains. And again, it's easy to get your toes wet with it, to just dip a toe into it. But you mentioned GIS in conjunction with Python a bunch of times. So I use it as a general purpose programming language, scripting language for automating tasks and things related to work. What do you use it for with GIS?
I mean, I haven't really used it a whole heck of a lot other than doing some basic functions. And to be clear, I have done experimental things. I have never really appreciated or done the full scope of what you can do in GIS with Python coding. And one of the reasons why I think QGIS is so great is QGIS, you're able to program stuff with Python. And I'm sure someone on here will come at me and say, well, you see, ArcMap, you can actually do this too. But at least with the Ohio Historic Preservation Office, their GIS tech, they use QGIS because he's able to program specific functions into their online mapping system that all the archaeologists have to use. And so he's constantly writing new code for their specific online mapping system so that they can have integrated tools that don't come preset with QGIS. And I guess that's that's sort of the bane and the blessing of QGIS, is it's open source. So people are constantly adding and updating tools and functionality to it. But if it doesn't have what you need, then you either need to hire someone to write the code or figure out how to write the code yourself with Python. So that's one of the benefits of using one of these open source GIS softwares, is being able to run all sorts of, I think he's able to run widgets with them. I could be wrong. That might be a HTML thing. I can't remember. But there was a specific tool that he had to make. And I wish I had written it down or remembered it. such a bad co-host. Didn't write down the specific tool, but those sorts of things you can do in Python or with Python in GIS. But as with all of these coding languages, I am knowledgeable enough to be dangerous, but don't go thinking that I'm going to be translating the Rosetta Stone with my knowledge of Python or R. And if I do, it's going to be with ample time and some reference material.
Well, I think it's interesting. You transitioned there from Python to QGIS. I was thinking we were going to GIS in general, but you went to QGIS in specific. And we've mentioned it in passing or in a little bit of detail a couple of times in the past, actually probably well more than a couple of times, because I know that you mentioned it just on the last episode too. Mm-hmm. And so for our listeners who might not be aware, I mean, you've all heard of GIS. QGIS is an open source, freely downloadable GIS package. It's extremely capable. Right. So you don't have to shell out the big bucks for the Esri products.
Right.
If you need to learn GIS, and probably even if you need to use it in a production capacity, QGIS, unless you're forced to use something different, can probably handle your needs. And then again, in the same sort of way that you were talking about the Reddit or the subreddits for R, and I'd mentioned Stack Overflow, QGIS, because it's freely downloadable and because so many people use it all over the world, there's a great open source community about it, right? So people ask questions, people help each other out. I know they've got a pretty good training manual online. We'll put a link to it in the show notes. Just be aware that it's keyed to the current version, which as of today's recording is 3.16. So you'll see in the URL right in the middle, it says 3.16. That probably won't be the current version when you listen to this episode. Certainly not if you listen to it, sometime in the spring of 2021 or later. There'll be a newer version out. It gets updated with some regularity.
But what's beautiful about open source software is that you are not obligated to update unless you run into a problem where you can't physically run the application. Like, you're not obligated to update. Now, obviously, if you're learning it, you probably want to learn it with whatever the most current version is.
Yeah.
But you could run older versions of QGIS until they run into errors or problems. Like, I don't think I'm running on the most recent version. I haven't updated it yet. But I remember this was one of my biggest complaints when I was in grad school and I got ArcMap. I think it was ArcMap the first year of grad school. And then literally a year later, I had to update it again because it was just like Microsoft requiring you to update every year, or SPSS, all these other sort of like name brand applications. They were like, yep, you got to update every year. Otherwise you can't use outdated software. And so that's just me saying, yay, open source. Like, I'm not saying you need to go down the rabbit hole and become a Linux head and, convert your computer. But that is one of the beauties of an open source software.
Yeah, absolutely. I was only putting that, you touched on it. The only reason why I was putting that caveat in there was because the assumption that somebody's going for the training manual is that they're new to it and they probably just downloaded the latest version.
Right.
But our listeners are smart. They'll figure it out. And then there are other resources out there on the web. You put GIS Lounge. Do they have tutorials directly linked out of there? I can't recall. I haven't used them in a while.
I think I've used a tutorial at a GIS Lounge once or twice, unless it was also a QGIS, like through their website. Right. But I mean, the sheer volume of GIS open access, like open software that you can download. I just go to QGIS because I think it's sort of you could correct me if I'm wrong because you also have GRASS in the show notes, but I think it's sort of the gold standard for open source GIS. Like, the only other competitor, like if you're not using QGIS at least in a corporate sense, you're probably using ArcMap or some Esri product. And even now these days, when you put GRASS as a separate product, I'll be honest, when I download QGIS, sometimes I get confused because it says with GRASS. So I'm like, Well, is GRASS a separate thing? And I guess it is. I don't know. I have not done a whole lot of research into what GRASS is. So maybe you want to enlighten me.
Yeah. So before we get there, I'm also going to plug a YouTube channel. It's Anthro Yeti. The owner proprietor of that channel is Edward Gonzalez Tennant. He's an archaeologist. He's been on this podcast before and does some great work, historical archaeology in Florida. But we'll put a link to his YouTube channel. He has a bunch of short little, how-to videos that are well put together and give you a sense of what's possible with QGIS, but also how to solve specific problems that you may have or may not even knew that you had until you start looking at it and see what somebody else can do. And that's one of the joys about playing with GIS is that, the deeper you get into it, the deeper it becomes and the more fun it can become if you're a mappy kind of person. And almost every archaeologist I've ever met is a mappy kind of person. So yeah, I did put GRASS GIS in here, and that's because that's what I used for a lot of the GIS work in my own dissertation. It's the old granddaddy of free GISs. It was originally done by the U.S. Army and got open sourced, and it's just like ours weird. GRASS is really, really weird. It is terribly old school paradigms. I do know people that do great work with it. It's still entirely functional. It still does get updated. It's free, freely downloadable. But that steep learning curve means that you probably don't want to start playing with it. And as you said, QGIS now has modules, plugins to be able to read and manipulate GRASS data. So that's what they mean when they say now with GRASS is that, I can open my project from 2004 in QGIS, my GRASS project, and I can continue working on it. I can run new analyses. I can make new maps. I can do whatever I want with it because it's built into QGIS, the ability to do so. And so that's a fantastic thing about that particular piece of open source.
I think that's probably a break point, right?
Yeah, let's take our second break here and come back for the third segment in a couple minutes.
You may have heard my pitch for membership. It's a great idea and really helps out. However, you can also support us by picking up a fun t-shirt, sticker, or something from a large selection of items from our TeePublic store. Head over to arcpodnet.com/shop for a link. That's arcpodnet.com/shop to pick up some fun swag and support the show.
Hi, welcome back to the Architect Podcast, episode 149. This third segment, we're going to round off our discussion today on kicking tech phobias. And we're going to round it out by talking about something that anybody's listened to this podcast in the past knows is near and dear to my heart, and that's relational databases. And I have a specific reason for talking about this, even though I often recommend that people don't build their own databases. I think it's very important that people understand how a relational database works. Because it can help you think about your data in cleaner ways that make it easier to do other things. So when we're talking about relational databases, there are a whole bunch of different ones out there. A few of them that you may be familiar with, FileMaker Pro, Microsoft Access. Both of those ones we're not going to talk about right now. Those are both kind of old school, soup to nuts engines and presentation mechanisms and form builders and all that for a relational database. That's not what I care about. I care about just really the back end part of it, the part that runs and manages the data and the part that you can directly query. Access and FileMaker Pro are being promoted less and less nowadays. You're going to run into them less. If you understand these other concepts, it'll make it easier to understand those ones. Then there are the biggies, things like Microsoft SQL or SQL Server and Oracle. Those are definitely not free. It's pretty unlikely that you're going to come across Oracle in most day-to-day work unless you're dealing with, some big funded agency.
Right.
Microsoft SQL gets embedded in a light version into a bunch of different products. And depending on what tools you have, you may or may not have access directly to the tables. You may only be able to interact with it through a front end of a program. So we're not going to pay attention to that either. What we'll look at instead, PostgreSQL, which is free and very robust, a little weird to use initially, so probably not the first one you want to try, or else MySQL, which you've almost certainly heard of, and MariaDB, which you may or may not have heard of. MySQL is funny in that it has different licensing models. So there is an enterprise version that they promote, and there's also a community version, and that one's free. MySQL was bought out by Sun, which was bought out by Oracle. And when that happened, the licensing changed. And in fear of what was going to happen to it, the project got forked into MariaDB. So MariaDB and MySQL Community Edition are basically the same kind of free open source database engines.
I did not know
that. You
that.
interact with them the same. They have the same flavor of SQL. And I'll tell you in a moment what that is. So if you can use one, you could use the other. Just so people are aware of that. When I say SQL, that stands for Structured Query Language, and that is the programming language that's developed in the 70s initially for querying relational databases. And it is, I find it actually a fairly easy programming language. It makes a lot of sense. It's not very deep in terms of like how complex you can do things. I mean, there are very complex queries out there, but it's really highly optimized for asking questions. Get me this from this table, match it up with that from that table, order it this way, group it that way, give it to me. And the other thing I want to plug here too is a product called MAMP, MAMP. That stands for Macintosh. Oh, what's the A?
This is all you. So
Apache. I forgot the Apache part. So Macintosh, Apache, MySQL, and PHP. And basically this is a bundled up version of those 4 different programs for doing some web dev stuff. So you run it on your computer as just a regular application. And there's both Mac and now Windows versions of it. So you don't have to install all these engines, which tend to be installed in Unix layers or in the operating system if you're on a Mac or Linux. So it's a simple way for you to download a complete package that allows you to start playing with these. What they don't get you is anything really to work with. It's just the engine that you would then play with for the data. And that's what I wanted to talk about. So I'm going to put a link in the note from something from University of Chicago about structuring data in spreadsheets. Mm-hmm. And that's because a lot of people use spreadsheets as databases, and a lot of them use them in very messy ways that make them very bad databases. Yes. I mean, we've all seen people format excessively in their spreadsheets to try to make something that prints out beautifully, but you then no longer can sort.
Don't use colors.
Colors mean nothing. Colors highlight. Right. So if you want to see something is good, you have it turn green. You want to see something bad, you have it turn red. That might work unless you're red-green colorblind.
Well, no, I mean, I'm more referring to, and I'm guilty of this myself because having not been formally trained in any of this sort of stuff, just being thrown into these giant data sets, like for projects where we would have 17,000 plus like projectile points on something and not given any sort of structure or guidance on how I need to organize them. And I'm like, I don't know what you need. So like, how am I supposed to organize this data not knowing what future demands for queries will look like? Right. And notice how I say queries and you say queries or whatever. So small linguistic difference. But yeah, I can't tell you how many archaeologists I've met who this single thing that you're talking about, relational databases, like if you could learn one thing about computers, please learn how to format your data. Because an Excel spreadsheet is not a database.
It's not, but it can be an okay one. It can be an okay one to learn how relational databases work. And so basically a relational database means that you've got one table that has all of one kind of object. You've got another table that has another kind of object, and they relate to each other. So anytime you look up tutorials on relational databases, they're going to give you one of 2 basic kinds of examples. They're going to give you a company and the employees in the company, or they're going to give you a list of products and a shopping cart example, neither of which are really good for learning how to use a database if you're an archaeologist. So what I recommend is that you fire up Excel or LibreOffice or whatever, or Pages even, not Pages, Numbers, the Mac one, and you make one sheet, because you can have multiple sheets in these. You make one sheet and you call it sites. And you give your sites, first column, just a series of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Next one, you give it a name. And then other ones, you give it other kinds of descriptors, coordinates, elevation, size,
landform,
type, landform, whatever you want. It doesn't matter. Just make sure that each column only has one kind of information in it, right? So if you have northings on your third column, that's northings all the way down. And eastings on your fourth column, that's eastings all the way down, right? And you don't combine data. Each column is distinct and discrete. And then you're starting to structure your data in a sensible way that will then translate into a relational database. On that second sheet, then make a second sheet on that same spreadsheet. Call it objects. I don't care what kind of objects. First column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Second, type, sherd, point, coin, doesn't matter. And then on the third column, give it site ID. And then what you can do is in regardless of what spreadsheet program you're using, you do something called a VLOOKUP. And you can get the site name or the site coordinates or whatever off that first one by looking up that third column in the second spreadsheet, in the second sheet, right? The one that says site ID. So I don't have to have all that site information for each one of these objects. I just have a reference that points back to the first one. And you do a VLOOKUP, you can look online to see how to do a VLOOKUP. They're very simple. But as soon as that clicks, I guarantee you will understand how relational databases work.
Oh, yeah. Yeah, I definitely think that's been one of the most difficult things when I teach my intro classes, not just archaeology, but also cultural anthropology, because I try to incorporate these concepts in all of my classes. This is the one that trips people up so much, is when I give them data and they're like, and I'm just like, well, you try and reorganize it. And I try to get them to think about the data in different ways. Yeah, I mean, I don't personally use VLOOKUPs, but that's mostly because anytime I'm doing analysis and whatnot, I'm not really generating giant databases, or if I'm doing something, I'm using it for like a one-off sort of analysis for something. I'm not generally, like, if I'm going to make something that's shareable, sure, I might use it, but I try to avoid, at least I've tried to in the past, because of how bad my experience has been with, like, especially Microsoft Excel and people just throwing stuff into it. And then the moment you have multiple people working in the same spreadsheet, chaos. Just version control is one of my biggest complaints with. And so as someone who's promoting VLOOKUPs in, say, Excel or LibreOffice, go open source, or OpenOffice, also an open source alternative to the Microsoft suite. As someone who's promoting VLOOKUPs, is there a way that you would recommend for, like, version control? Which, for those that don't know what version control is, essentially, if I make an update on a particular document and you make an update on a particular document, they can merge together, and that you don't end up with 5 different iterations of the same document because someone's working on an older version of, say, the same spreadsheet, but they don't upload it to the same source, and you're also working on it at the same time. How do you reconcile both those people's different edits on different documents? So what do you recommend in that case?
I don't have a good recommendation for Excel spreadsheets or LibreOffice, OpenOffice spreadsheets.
Case closed then.
Well, no, what I would say is use one of the online tools like Google Sheets. They're becoming increasingly useful. We use them all the time at work, and they're made for multiple people to be editing at the same time. It also has a built-in, not a great version control. You can't do like real merges and diffs and such like you can with text that's in Git, like you would do with your source code. But you can certainly find where things went awry when somebody accidentally, types over data in a cell. It's like, oh, that was Bill last week.
Do you use anything other than Google Sheets then? Because not that I have anything against Google, but obviously I would love to see alternatives to big tech if there's an option.
Yeah, no, I don't. I'm sure you could use Office 365's Excel, but that still keeps you in the world of big tech. I do believe that you can do something similar with Numbers, Apple's version, but that still keeps you in the world of big tech.
I wonder if you could make a server, like your own personal server, like a Raspberry Pi server, and then just share that with the people that need to have access to the spreadsheet. And then maybe...
No, you know what people do? If you're not doing a spreadsheet, if you're dealing with CSV, columnar data, people do use that directly in Git. Right?
See, because I toyed around with that a year or two ago, and I just never followed up with it because I couldn't find any conclusive information on using because really CSV is probably all most of us archaeologists need, especially some of us older archaeologists who only think in terms of like spreadsheets where it's like frequency, counts, descriptions of things. You're not really doing any functions inside of these cells. They're just describing some attribute about an object or a site. So you could do most of it in a CSV file.
Yeah, I'm trying to remember. It was years ago. I saw a lecture by Sebastian Heath. He's a professor at the Institute for the Study of the Ancient World here in New York. And he's actually been on this podcast too. But he had locations and dimensions of Roman amphitheaters, I believe, all in CSV on a Git project that he was working on to map them in R. So maybe I'm going to do this and then we can wrap up our discussion here. But that's why I wanted to talk about relational databases, because R and Python are great for data analysis. GIS is great for data display and also for analysis. Python certainly can be used for data display, depending on what you want to do with them, what different modules or plugins you have. But they all can benefit from an understanding of these relational databases because it helps you think about how your data are structured. And specifically because all of those different things, QGIS, Python, R, they all have different ways of hooking into your relational database.
Yep.
So you can use the database, a tool for the job, for storing all your data and having it managed and clean and not monkeyable. And then you can do your work by grabbing that data, pulling it into whichever other tool you're using, and then processing and displaying or reprocessing. Feed it back into a database if you have to, whatever you need to. But these aren't competing technologies. These done right, these are really complementary. And I think that's worth looking into for no other reason than I think it'll open up your eyes to different things you can do. But
I almost feel like
out of time here. Oh,
I know, but I almost feel like we could have our own separate episode talking just about databases and how to manage data organization and the best tech for it. Because I do think that's one of the biggest banes I encounter in the workplace is interacting with other people's data and then trying to manage these big research projects where you have like 10 people all working within the same data and, version control and all that kind of, I think there could be a whole episode talking about relational databases and whatnot, which I'm sure your ears are pricking up at the prospect.
Oh yeah, absolutely. No, maybe Eric, you and I ought to do an experiment about like how to manage data distributed amongst different people and how to, because we're not the only ones to look at this. Lots of people are dealing with this. There's a whole data science community out there that is dealing with this at a very intense level day to day as parts of their jobs. Maybe we ought to play with some ideas and see what we could present as another future episode.
I could even give you some free data to play around with that. I mean, eventually it'd be nice to have data that is publicly accessible. So then people who have an interest or want to do research, can just literally download the data. But that's also another discussion for another day for those old fogies that think like if you give site coordinates to someone in Ohio, they're going to just go out and loot the site, but not when it's under a Walmart parking lot. But
Chris
anyway,
always says that that's the best way to preserve a site is just plant a Walmart on top of it.
Yep.
So let's wrap up the last couple of minutes here. We're talking about kicking the tech phobia, and you had some very specific ideas based off of your own experience about how to experiment with code and what works and what doesn't work.
Yeah. So at least in my experience, I found taking a structured course, whether you're paying for it or not paying for it. So it could be one of these, massive online classes through like MIT, which also they offer a ton. You could take one through your local community college. Hey, got to plug Tri-C there. We offer some data science certificate programs, which I myself am taking. But also don't forget to think, maybe put on like your teacher cap. Even if you aren't a teacher, think about if you were trying to teach someone this code or this particular tech tip, how you might teach them if they aren't getting it the first time. And remember, that advice might apply to yourself. Don't beat your head against the wall doing the same thing. Try new approaches. So if MIT's system isn't working for you, maybe try a different online course structure. Or maybe you just open up a application and you just experiment with it and you start playing around and you give yourself a goal or start small with a small task of like, I want to figure out how to do a simple math problem in Python. I mean, that in itself can be a learning experience, trying to figure out how to accomplish that goal. That might not be the most efficient way, you might learn later, but it will definitely get you to start thinking in a different light and start to process and understand things, I think, a little bit better. And one thing you could start with is I've developed 2 educational games that we can put in the show notes. When you download them, you have access to the raw script, which incorporates both Java and Python. It's run through the application RenPy, which I guess is its own sort of language, but you can follow along, and there's also documentation for that as well. You can follow along, and if you have the game open, you can literally look at the code and watch, or just scroll down the script and figure out, okay, line by line, this is what it's doing to show me the image on the screen, or show the text, or cycle through an animation, or prompt me with a choice and a decision. Maybe that's one way that works for you, is reading and trying to translate. Just know that there's no one perfect way for it to work, and don't beat yourself up or think that you can't learn it just because this one way of teaching yourself or learning it is not working. There are many different ways. Or I'll throw this out there because I know we're running short on time. There's an entire Discord server dedicated to R. And if you're not familiar with Discord, it's essentially an online chat room that, at least so far as I can tell, is quickly replacing most other sort of social media like Facebook. All the Discord servers I'm finding are either filled with, kids 11 to 18 or adults my age in their like 20s and 30s who are professionals trying to find other professionals. And there's an entire Discord server dedicated to R called Discord with a capital R. I know it's not it's a clever name, I guess, but
pun,
they have I'm not sure if you
pun from computer programmers. I can imagine.
Yeah, I know, right? But you can have live conversations with other people who are learning. They provide documentation, and what's beautiful about these communities, whether it's Reddit or Discord or other online forums that you would use, is that I feel like in general the coding community is supportive rather than putting down of people. They want other people to learn, because when other people learn, they can learn through teaching. Just as I said, put on your teacher cap. We learn through teaching other people just as much as you can learn from being taught.
I'm going to add one last little thing, though I would love to end with learning through teaching just as much as learning from being taught. But when you're doing these small projects, remember all the examples you have. And I've seen so many people comment on this who've written computer programming textbooks. They all say the same thing. Those code snippets that you see are edited just like the rest of the text. That's their 5th or 10th or 20th time through to make something work the way that it looks like it's so simple, like they just rattle it off. You will fail a lot with your small, simple tests. Don't let it get you down. Keep the test small so that when you fail, you don't fail too hard, and build up. But know that it's probably not going to work the first time. And that is not just okay, but it's also a learning experience. Why didn't this work?
Yeah. Get comfortable learning how to read an error message.
Yes. All right, Eric, let's wrap this up. Thank you so much for coming on and having this interesting discussion. I hope that our listeners learned something, and I know I certainly did. I'm going to again go and play around with R some more, just because it is fascinating. Even if it doesn't work the way my brain works, maybe I just have to try a different approach.
And I'm going to play around with Git some more and GitHub and see if I can't set up some version control CSV relational database that we might be able to work with, because I think that'll be fun.
Yeah, definitely would be. All right, everybody, take care. Remember, wear your mask, wash your hands. We're not out of this yet, and I'd really like us to be. Bye. Thanks for listening to the Archaeotech podcast. Links to items mentioned on the show are in the show notes at www.arcpodnet.com/archaeotech. Contact us at chris@archaeologypodcastnetwork.com and paul@lugal.com. Support the show by becoming a member at arcpodnet.com/members. The music is a song called Off-Road and is license free from Apple. Thanks for listening.
This episode was produced by Chris Webster from his RV Traveling America, Tristan Boyle in Scotland, and the Archaeology Podcast Network, and was edited by Chris Webster.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.arcpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.
Thanks again for listening to this episode and for supporting the Archaeology Podcast Network. If you want these shows to keep going, consider becoming a member for just $7.99 US a month. That's cheaper than a venti quad eggnog latte. Go to arcpodnet.com/members for more info.